Okay, so now we're going to finish the last half of this section, and we're going to be doing some problem solving with inequalities. It says certain phrases can be translated into mathematical terms using inequalities. Below is a list of the common ones. Okay, so there's words such as at least or no less than. If you see those written in words for something that you're problem solving, you want to know that that means greater than or equal to. If you see words such as at most or no more than, it's going to be less than or equal to. You see the word between and inclusive. So just between means that it unknown is going to be between two things. And it's going to be, if it's inclusive, it includes those two numbers it's between. So let's practice. It says define a variable, write an inequality, and solve. The sum of two consecutive odd integers is at most 255. Find the pair with the greatest sum. Okay, so I'm going to let x equal the greatest or the bigger, the largest, however you want to say it, of two consecutive odd integers. And then, so the sum of two consecutive odd integers. Okay, so if that's the bigger one, then the smaller one is going to be 2 less than. So this is going to represent the smaller of two consecutive odd integers. Okay, now it says their sum, so that means I'm going to take the largest of the consecutive odd, which is x, and I'm going to add to it the smaller of the consecutive odd integers, which is x minus 2. And at most, if I go to my list, at most up there says that's less than or equal to 255. So now I'm going to solve it. X plus x is 2x, minus 2 is less than or equal to 255. I'll add 2, and when I do, I get 2x is less than or equal to 257. When I divide by 2, it does not go in there evenly, so I'm going to get x is less than or equal to 128.5, which I just wrote as a decimal. So the sum of two consecutive odd. So first of all, 128 and 5/10 is not an integer because it has the decimal with it. So if you think about what comes before that, that's an integer, is 128, but 128 is not odd. So the greatest one that's going to work is going to be 127, and then one right below that, which would be less than, would be 125. So the two integers, well, I didn't leave enough room here. The two integers are 125 and 127. Okay. Let's go to the next one. The length of a rectangle is 6 centimeters shorter than its width. The perimeter is at least 60 centimeters, and at least is up here. That's going to be greater than or equal to. What are the smallest possible dimensions for the rectangle? All right. So let's look and see what it's saying here. The length of the rectangle is 6 centimeters shorter than it is wide. So we'll let L equal length. And of course, W is going to be width. The length of a rectangle is, so L is 6 centimeters shorter than the width. So that's going to be W minus 6. We know that perimeter of a rectangle is twice the length plus twice the width, and it says at least. At least means greater than or equal to 60. Okay, now I'm going to take, and wherever there's an L, I'm going to put in W minus 6. So this is going to be 2 times W minus 6 plus 2W is greater than or equal to 60. I'm going to distribute and get 2W minus 12 plus 2W is greater than or equal to 60. 2W plus 2W is 4W minus 12 is greater than or equal to 60. I'm going to add 12, and I get 4W is greater than or equal to 72. When I divide by 4, W goes in there evenly, so it says W is greater than or equal to 18. And now it says, what are the smallest possible dimensions for the rectangle? Well, it can equal 18, but it also means it's anything, let's see. What are the small? Yeah, so 18 is the least it can be. So let's put that back in and see what we get. So we get length equals 18 minus 6. So we get 12 for the length and 18 for the width. So the smallest dimensions are 12 centimeters by 18 centimeters. Perfect. Okay. Sam scores on her first 4 tests. There, she got an 80, a 65, an 87, and a 75. What will she have to score on her next test to obtain an average of at least 80 for the term? Okay. At least means greater than or equal to again. Okay. So we're finding an average. How do we find an average? We set them all equal to, we add them all together, and then we're going to divide by however many we have and set up the inequality. Okay, so what she's taken 4 tests, so let's let X equal the score of her 5th test. So we have 80 plus 65 plus 87 plus 75 plus we don't know the 5th score all over how many tests? 5. At least an 80%. Okay, I'm going to get rid of the fraction. I'm going to multiply through both sides by 5, and then I'm going to get 80 plus 65 plus 87 plus 75 plus X is greater than or equal to 400. When I combine and add up everything, I get 307 here plus X is greater than or equal to 400. I'm going to subtract 307. And when I do, I get X is greater than or equal to 93. So Sam will have to score at least a 93 to get an 80 for the term. Sonia is a waitress. She earns $200 a week plus 15% plus a 15% tip on the cost of each meal she serves. What must the total cost of meals she serves be in order for her to earn at least, again, we're having a lot of at least, that's greater than or equal to $425 a week. All right. So it's asking us, what must the cost of the meals served? So let's let C equal the cost of the meal. So she already earns $200 a week already. But then she earns 15%, that's 1,500 as a decimal, times each meal, so that she can get at least $425. Okay? I'm going to get rid, well, let's do this. Let's go ahead and subtract the 200. And that'll give us 1,500 C is greater than or equal to 225. If you don't want to work with the decimal, just go ahead and multiply it by 100, and you'll get 15C is greater than or equal to 22,500. We're going to divide by 15. That does go in evenly, and then it gives you 1,500. So what is it asking? What must the total cost of meal she serves be? The total cost must be at least $1,500 for her to earn $425 a week of the meals must be $1,500. Okay, one more. I have 26 coins, some which are dimes and the rest are nickels. Altogether, the coins are worth more than $2.10. Okay, we've got the more than. If we go up here and look for more than, it looks like it is going to be just a greater than symbol. Just more than. Okay, at least how many dimes do I have? Okay, so let's get some things. Let's say D equals the number of dimes. N equals the number of nickels. And together we have 26 coins. So I have nickels plus dimes equals 26. And then from here, if I want to solve in terms of one of them, I'm going to subtract D and I'm going to say nickels equals 26 minus D. So I'm going to keep that for a second. So now let's make our equations. So we have nickels plus dimes is greater than 200, no, nickels plus dimes, yes. It has to be greater than $2.10. Sorry about that. What is the value of a nickel? It's 5 cents. What is the value of a dime? It's 10 cents. Okay. But now I'm going to replace so that I can solve it in terms of one variable. I'm going to go ahead and put this in right here for nickels. So I'm going to have 500ths times 26 minus D plus 1000ths D is greater than $2.10. I, of course, will get rid of the decimals. So this gives me 5 times the difference of 26 in D plus, and that's 10D is greater than 210. I'm going to distribute. 5 times 26 is 130 minus 5D plus 10D is greater than 210. I'm going to combine my like terms. That gives me 5D. I'm going to subtract 130. That's going to give me 80. And I'm going to have 5D. It must be greater than 80. 5 does go into 80. It goes in 16 times. How many dimes, at least how many dimes do I have? So D is greater than 16. So the next integer would be 17. So you have at least, or I have at least 17 dimes. Okay, so we've finished the problem solving portion of this. I have posted your assignment, so go ahead and do that, and feel free as always to message me if you have any questions about any of it. And I hope you have a good rest of your day.